Ladies and gentlemen, welcome to ICSE Industry Forum, amazing panel of tomorrow. And please find your seat and we can get started. We have here, the panelists have arrived, the microphones are set, the ammunition is ready, and today we are proud to have in our panel, and I would just briefly explain what we do, and we get started. It will last 60 minutes, and by 5 o'clock we are done. So we will talk about the software engineering in 2030. The panelists we have today, Markus Borg from the Swedish Institute of Computer Science, 6. Then we have Liliana Pasquale from Liro in Ireland. And then we have Caitlin Sadowski from Google. And the smiling gentleman over there is Tom Zimmerman from Microsoft. And Lionel Briand from University of Luxembourg. And finally, we have Mark Harman from Facebook himself. And I heard Facebook is hiring, and that's always good news. Mark told me this is a small sales pitch here in the beginning, but enough of that. It is time to get to the panel itself. So I will, now that we talk about 2030, so we will start by asking these panelists this question: what is the thing that they do not want to see happening in 2030? So rather than starting by saying that this is what I dream, let's hear what they don't dream of. So I start by so Markus Borg will start, and he holds a PhD from computer science as he's working as a senior researcher at 6. And he still retains 1 foot in academia and works as an adjunct senior lecturer at the Lund University. And with these few words, Markus, what do you do not want to see happening in 2030? Please.
Yes, please. So, yes, the microphone works. That's good. So we thought software was critical in the beginning of the new millennium, and it was. And we think software is critical to society now, and it is. But in 2030, things will, of course, be even more so. We'll see bigger systems, more complexity, and more time pressure on the development. But software businesses will prevail, will keep disrupting various industries. And one of the most disruptive technologies we see at the moment is machine learning and deep learning, especially as we already saw today at more than one of the keynotes, actually. And this is very handy when you're primarily interested in finding patterns in big data. And we've seen some amazing breakthroughs in for various applications, playing AlphaGo, translation, speech recognition, and of course, perception as it is used for self-driving cars. And we read about that in the news almost on a weekly basis. However, this realizing system features using machine learning, it's of course still software. And I feel that our part in this, the software engineering community, is maybe not recognized enough. And to some of the more trendy data scientists, we might even be the dinosaurs. But we are needed here. We really are needed. We need to step up as a community. We need to ask the right questions. We need to invent systematic engineering approaches for how to develop those AI-based systems. Because if we fail to do that, and I'd hate to see that, then things will get dangerous. And not only because of the obvious functional safety of autonomous vehicles, it's larger than that. It's about you and me and all of us, and using deep learning to find patterns among people. And,
thank you, Markus. To those dangerous words, we will now.
That's a good final word, yeah.
Stop, and now we move on with Liliana Pasquale, and she's a lecturer at University College Dublin, Ireland, and also she's a member of the Liro Irish Software Research Centre. And she's her research interests are centered around requirements engineering and self-adaptive systems. And finally, she has a PhD from Politecnico di Milano in Italy. And finally, really finally, she holds a blue belt in Brazilian Jiu-Jitsu. So what are your words about the future that you don't want to see happening?
Okay, so we are seeing an increasing widespread of IoT technologies, and they have 3 main characteristics. So they are cheap, they are very personal, and very invasive. So What I would not like to see in 2030 is the fact that these are not invading our privacy, but the fact that software can also affect our decision and what we do in our lives. So this is the first thing I don't want to see, like software becoming so pervasive that could even affect our capability to decide in an impartial way. The second thing I don't like to see is the fact that the increasing widespread of this technology is blurring the boundary between cyber, physical, and social spaces. So that means that attackers can find different ways to compromise software system from people, from software, and from physical spaces. So what I would not like to see is the exploitation of cheap technology to cause harm to people and institutions.
Thank you, Liliana. Now we move on. Now we have the answer is coming from Caitlin Sadowski, and Caitlin is working at Google. Her mission is to improve the developer workflow at the company. She has worked on a variety of teams with this focus, and currently is helping Google Chrome developers to make data-driven decisions as the manager of the Mountain View Chrome metrics team. And she has a computer science PhD from UC Santa Cruz. Okay, thank you. So what do you do not want to see in 2030 happening?
Well, as code gets bigger and bigger, it's difficult to understand. So what I don't want to see is we understand our code even less. Software gets larger faster than we were able to verify it or understand it or reason about it. And I don't want to see a software system upgrade to the US government costing $1 trillion as a result of this.
I agree.
Could imagine something like that. And related to that, the issue of understanding, I don't want to see documentation kind of getting worse and worse and people not caring. And I also don't want to see the field being as homogeneous in terms of people that practice it as it is right now.
All right, thank you for that. I didn't know that the systems are, is there $1 trillion price tag on the system now in US? Must be in US.
Not for a software upgrade. That would be the unwanted future. That when it comes time to upgrade to a version of the system that actually works with some new technology, it costs that much.
All right, very good. And now we are going further. So Tom Zimmerman is working, he analyzes data for a living. And he also collects unicorns in his office. Currently, he works on productivity of software developers and data scientists at Microsoft. And in the past, he has analyzed data from the digital game, branch structures, and bug reports. And he has a PhD from Saarland University. So go ahead.
Yeah. So the unwanted future is, I think it's a bit related to Marcus and Liliana, is because we're collecting much more data now as part of software development. When software is in production, there's so much data collected now. And there's a huge opportunity to use this data for something useful. But I think there's also a risk that comes with this proliferation of data collection, data analysis, and also user profiling. Because there's easy a potential for misuse, and I think we have seen some examples over the past few years. And I think as AI techniques advance more and more, and we collect much more data, I think the risk, the potential of risk increases further. So one solution is, of course, that people don't use any software system where we might give up some of the data. But in reality, this is also not possible because at some point you can't just avoid being on the internet. You might have to use software to do your taxes over other critical systems. So the other concern I have is that as AI-based software gets more and more complex, it really gets harder to understand, and there's like a chance that that there's basically software-based discrimination, that based on like the training data that you use for your systems, you discriminate against certain populations unintendedly, and in some cases, and that's even worse, is that there might be intentional software discrimination. The other concern is that like there is a growing divide, I think class divide between people who are in STEM and people who are not. So if you're exposed to technology, engineering, mathematics, you have a better chance to succeed in society. And I think that's something that we need to watch out, because with more automation and more digital systems, there's like a risk that the more jobs are going to disappear, and we need to make sure that these are still.
Thank you, Tom. I think that that will conclude the position, and we move on to Lionel Briand, who's a professor in software verification and validation in University of Luxembourg, where he's also the vice director of the research center. He runs currently multiple collaborative research projects with companies in the automotive, satellite, financial, and legal domains. So, Lionel, go ahead.
Thank you. From a purely research perspective, what I would like not to see in 2030 is having a large proportion of software engineering research being mostly disconnected from engineering practice and relying on unrealistic working assumptions and focusing on problems that either don't exist or are secondary problems in practice. So that's what I would like to avoid, in the future.
So you are saying that we should become more like a mature engineering discipline?
Yes, that's another way to say it. But we need a larger proportion of the research that is being presented here at ICSE or other forums, research forums, that results from basically a better, more thorough understanding of engineering practice, what the problems are, what are the conditions under which solutions can be devised. And basically, we should avoid having software engineering academics mostly talking to each other. We should, let them go in the wild and fight real problems.
Now we move on, and the final unwanted future will be laid out by Mark Harman, who is an engineering manager at Facebook in London, where he manages a team working on search-based software engineering at Facebook scale. Mark is also a part-time professor of software engineering in the Department of Computer Science at University College London. Go ahead, Mark.
Thanks, Pekka. So I'm going to say two words, and I want you to think about what that conjures up for you. Software tester. Many of you are probably imagining a human being. At the end of the 19th century, if I said to you computer, you would also be imagining a human being. Doesn't that seem quaint now? So what do I not want to see by 2030? 3 words: manual software testing.
But nobody's testing manual anymore, is it?
No.
All right.
Great, we're already in 2030. How nice.
Time travel.
All right, so the way we will go forward now is that now that we have gotten off our system or chest this, what we don't want to see, we will now look into what the panelists are thinking that the future actually will be. So please record now what will be said, because we will come back in 2030 and we will look at this from the video and see how the predictions actually turned out. After that, when we have gone another round through, we will open the floor for questions. So I have now collected about 50 or 60 questions from the audience during the break. But for those who want to ask a question after the second round, you can line up behind the microphone. Microphone is here, so I will come and give it to you. And you can then ask questions. So we take one always from the backlog, and we take one from the audience, and that's how we move on. But the future, as you dream, wish, or predict it to happen, what is software engineering of the 2030 all about? And I think we start with Mark, because Mark can continue now with his statement, and we come back from there. So Mark, please.
Well, it's very dangerous to make predictions, especially about the future. And this is 12 years ahead, which is longer than most of the research grants I've ever held.
But it's more fun to predict the future than the past.
predicting the past would be easier. So I personally really believe in this idea that we can automate not just the process of testing, but also some of the process of software design and software development. I think that the work on genetic improvement, program synthesis, and automated construction of software systems is really exciting. I think that rather than trying to do what perhaps somewhat naively we tried to do in the past and grow systems completely from scratch, we're now realizing that there's already billions of lines of software, and all we really need to do is take the existing code and modify it a little bit. The way I think of it is, instead of trying to grow human beings from amino acids, which can be done, we're all evidence that this works, right, by an evolutionary process, but it takes billions of years. Instead, if we start off with apes already, then we can very quickly grow humans. And by analogy, I think if we start with existing systems and search for small modifications that improve the behavior of those systems, we'll get a lot of traction with the problem of automated software design. So by 2030, I'd love to see this as common practice, both as exciting academic research problems and also within industry.
All right. That is a prediction made. Thank you. Lionel, go ahead.
Again, I'm going to take a purely research perspective here. I decided to focus on this. What I'd like is to see more interdisciplinary research in software engineering that accounts for domains and contexts. So for example, what I would like to see at ICSE is a track on, let's say, software engineering and robotics, software engineering in autonomous machine learning-based systems, software engineering in medical equipment. That's what I would like to see. And also, another thing I would like to see at ICSE is no SCIP track. I mean, basically a research track that merges what is called now the technical program and SCIP, where engineering research is simply research.
What about if we leave the research out, what is happening with industry by 2030? If we don't consider the research,
I mean, again, I don't want to predict, because I don't think anybody 15 years ago could have predicted what is happening now. When I did my PhD, it was a while ago, but about 25 years ago, my PhD was half on machine learning and half on software engineering. And you can't imagine the level of content that computer science and even artificial intelligence academics had for machine learning. It was considered the lowest form of research, considered to be, a maverick field of research, This is not so long ago, So predicting what will happen in 15 years, I'm not too sure. But, of course, we could follow the line of thought, that Mark just elaborated upon, and we could say that, well, we expect various forms of artificial intelligence to automate many of the tasks that are done today by
There were quite many questions about what happens with the AI and how does it impact on software developers. One question was that when do we finally get the robot programmers doing the work? And so robots and programming, is that reality?
No, but as Mark just said, you can get a lot of automated support. You can, for example, be provided with design alternatives or source code that is the closest to what you need that you could modify, or with even suggested changes. I mean, we can imagine that, but of course we have absolutely no idea. Those are just dreams, or dreams or nightmares, I'm not too sure. But,
Markus, now it's time to disagree.
Time to disagree.
No, I don't have to disagree. I'm just making sure that you stay awake there as well. So let's move on to Tom, and you can disagree if you want. So Tom, go ahead.
Okay.
I'm confusing the panel now because it looks like people are very comfortable now in the panel. So it's time to do some surprises. So Tom, go ahead.
Okay, well, I'm going to make a prediction. We're going to be more unicorns in 2030. No, so what I think is going to happen is that we're going to see much more end-user programming in 2030. So it's going to be more people who write some form of software, do some automation where they automate some aspect of the daily life themselves so that it's customized to their needs. And we also have ways to share whatever automation we did, we can share with other people. So I don't know which form it's going to take. It's very likely going to look different from programming, but we will see. So actually don't like end-user programming so much in this context. I think of it more like do-it-yourself programming. I think there are also going to be some changes to traditional programming. I think we're going to see much more automation, like in testing, because AI can help us to just automate some software engineering tasks, which are like not as easy to do right now and require a lot of manual effort. I don't know yet if we get to self-writing software, so that's going to take, I think, a bit longer. I think we're also going to see, so what we're going to see is much more software which has some AI component. And that's something that we really need to think about, is because it's going to be much harder to understand the software. So basically we have to think about how we can get away with understanding less software. And yeah, I think that's it pretty much.
All right, thank you for the predictions.
Yeah.
Let's move on.
I like to be wrong.
Okay, Caitlin, your turn.
So I'm focusing on what I wished it to be like instead of necessarily what I predict. But I think program synthesis will play a larger role, as Mark mentions. And then practitioners will have tools to understand what just got generated and why. But we won't have too much synthesis. Programming will still be fun. There will still be enough interesting challenges. It won't be just all you press a button, it does it for you. I think related to that, we need better documentation. So I'd like to see documentation generated and answers questions before you even think of them. You have the documentation that you need and it's accurate. I think that concurrency will actually be important. So there's like the end of Moore's law, and we need to start thinking about writing concurrent code all the time. But it turns out that we were kind of sloppy for a long time, so we didn't really need to start thinking about it right away. But now that sloppiness level has gone down, so we're kind of getting to the wire. So I think everyone's going to need to start thinking about the distributed world. Paxos is the new quicksort. I also would like to see all code, basically, just standard has tests. It goes through code review. It has static analysis results. That's just what programming means in 2030. And that it is easier to see design trade-offs. So like automatically, not just when you're deciding like sort of micro things, but like, how should I structure my application? Information on that to help you in the beginning.
Kaylee, maybe you can say something about, there was a question about how deep and broad should the T of the professional software engineering in 2030 be? So I guess the one who asked the question wants to know about the kind of competence profile of the developer. What type of developer you would like to see? Are the competencies the same, or how are they different? Do they have a different look and feel?
So I think, like Tom mentioned, like DIY programming, I think you said. So like, not just end user programming, but like people. So sort of, we're already seeing this sort of everyone can program to some extent. So I think I would like to see that. I think there's also going to be a sort of specialist programming career for people that have sort of ability and interest in like a lot of analytical thinking and that kind of finicky talking to a computer stuff.
All right, Markus wanted to jump in.
So I think you actually also answered this in your previous statement because you talked about diversity. You don't want to have a homogeneous set of developers.
Yes.
So I guess diversity.
So that too, I would like to see.
So then you have different skill sets also
yeah.
among the developers, I think.
Yeah, more people from more countries, more from more backgrounds, more women.
Interdisciplinarity, as Lionel also said.
This is a big topic, this interdisciplinarity and diversity. There's a loads of questions about diversity. Markus or Caitlin or anybody actually, what is your solution to bring diversity in the field as a whole, in the research, in the education, in the companies, in the teams, in the leadership?
I don't think there's just one solution.
I'm hoping there's only one that we can quickly fix it. But what are you thinking? What are the ways Google is doing this as an example?
So Google is doing like a whole bunch of different things related to this. So I mean, we're taking a close look at our hiring practices and making sure that we get like the right people into the pipeline in the first place. So we still have like a technical interview bar, but like really making sure that we talk to enough people. We're also doing a lot of things from an education perspective. So like we have a program where Google developers can go teach at historically black colleges in the United States because there's a smaller percentage of black programmers. And in order to change that, like part of the problem is that the schools that we had sort of like recruited a lot of people from also have a small percentage of black people in the computer science department. So if we want to find more people that are black and are going to be a programmer, then we have to look other places. So helping change the education system around that.
I think we can come back to that. I think that Caitlin's waiting eagerly to share your prediction.
Another comment, actually.
And you can comment as well.
Yeah, in Ireland we have a similar situation, but the schools are segregated. So it means that male and female attend different schools most of the times, and the subject they can study is different. So in many schools, females don't have access to computer science or technical skills still. So what we are doing in UCD is to have programs that could teach computer science to last year girls, so they could have more possibility to access to a computer science degree.
All right. Would you like to continue now on the prediction side?
So I don't know if it also relates to diversity, but I think another thing I would like to see is that software engineering, I think it's a tremendous opportunity now, because software is becoming so widespread in our lives. We really have a duty and the opportunity to build software that satisfy values and ethics principles. So, and for examples of principle could be fairness, the possibility to build software that don't bias decision, or that doesn't affect what we have to think about, what are the standards, for example, about how people should look, and so on. So I think this is an opportunity, and also the idea that people don't just can control their privacy, but can also control the type of information they can receive. The second thing I would like to see is to have security and also ethics and privacy and forensics requirements to be taken into account when software is developed. Still, I see that the majority of software developers focus on functional requirements, and I think that's wrong because now, because software is becoming so cyber-physical and is affecting our decision, we also need to take into account other type of requirements when we build our software.
There are already so many methods, and now you have to start taking ethics into account with all the good old elites. So should we come up with new methods, or how do we fix this method mess?
Okay, so there is the first problem in this domain is that it's very hard to understand what ethic is, because it depends on the personal, on the people, it depends on the company, it's also something that is very hard to represent and formalize with what we have so far. So I think it's a really complicated problem that is worth addressing and for our community.
So for now, we don't have an answer, actually.
I don't have an answer, but I don't think what we have so far is sufficient, because ethics is a concept that is so abstract and so different that it's very hard to represent and formalize.
But moreover, we have these methods. We have Agile came, and Agile is now everywhere. Even Microsoft is Agile. Okay, Tom, you're awake. Good.
Well, I think Agile method provides the opportunity to integrate people who are your stakeholders in the development life cycle, and these are the people where this type of requirements can come from. So I think that's an opportunity also for people who are working on Agile.
Yes, I think that, but the thing that what I'm a little bit looking after here is that and this was one of the questions made by the audience, is that what is the future method that we are following? Is it the next evolutionary version of Agile? Now everybody talks about SAFe. Nobody studies SAFe method, but everybody seems to be using it, scaling Agile. But we have the safety, we have verification, validation approaches. Is tomorrow's work going to be yet a number of new approaches to fix the future problems? When we figure out what is ethics, then we can have a method for ethics.
Okay, so I don't have an answer to your question, but okay, so this is an observation that actually came from a lunch discussion. So I think software engineering, the reason why software engineering doesn't have the ultimate methods and is not still so immature is the fact that there are so new technology coming up that it's very hard to consolidate a software development methodology like, for example, you have in other engineering disciplines such as architecture and stuff like that. So now you have IoT devices that will require a novel programming paradigms. You need to include ethics value. And that's why I think one of the reasons why our discipline is still not maturing enough.
All right, there was one comment was that should we stop calling software engineering by 2030 software engineering and call it software science, what it is?
Hell no.
And this was the one who made the question actually said that Lionel will have an opinion on this. So, what is your opinion?
Lionel always has an opinion on everything.
All right. Well, you know, I don't know.
I guess it's no.
You know, it's not sure how.
That's a first.
How much time that question deserves, but I mean, what is it in software engineering that is not engineering? What arguments can you provide to describe software engineering as anything else than an engineering discipline? I mean, of course, engineering disciplines are always based on science. I mean, electrical engineering is based on physics, among other things. You know, but that doesn't make them less. That doesn't make them anything else than an engineering discipline anyway, because the research is and the innovation is problem-driven. It's always a matter of.
Is anybody, by the way, here objecting to Lionel? So a different opinion. Now would be a great time to get some fame.
Right.
Well, I know you want some controversy, so I'd just like to say I really hope we don't spend the next 12 years discussing what we should call it.
I agree.
We'll look like the Galgafrinchans in Hitchhiker's Guide to the Galaxy discussing what color the wheel should be.
Thank you for that. I think we have to move on. Markus, predictions of the future.
Yeah, thank you. So I will actually also eventually reach some ethics and diversity in this statement, but I want to start in the machine learning end again, reconnecting. So I think in 2030 we'll have a very healthy interplay between machine learning and software engineering. No longer we'll have this trial and error style to machine learning. We'll have more engineering practices. I hope so, at least. I mean, I really hope that. It will not only be about how to develop the systems, also how to maintain them and evolve them over time, because this is very important for those extremely data-driven systems. And about the data, I think we'll see a move here. So this is a prediction towards more openness. We have open science, open source. We have open innovation. We see more also of open data, I think, when you share high-quality training data between different organizations. And for some domains, it might even become so important and fundamental that it gets regulated, perhaps in traffic. We don't know that yet. There might even emerge companies that specialize in providing this special training data to help you train your systems. We'll have commodity data. Everyone has that, and then we'll have some differentiating data that actually brings an edge to the market. But yes, when you have this extremely data-driven kind of products, then diversity, of course, it is super important. And you have to make sure that you have developers that actually cover all parts of the population. We've seen some really disturbing and embarrassing examples when this was not the case. But do I get more time?
You can finish the argument.
Oh, just want to say, I think it will be more diverse in 2030, and both in terms of gender balance and also in terms of...
But the big question here is, what are we doing about it? I think that is the key, and we had some attempts, we have some, but is the strategy working?
We have one thing that I want to bring up then. I mean, for a start, we have finally managed to get programming into the school's curricula here in Sweden. Starting this year, everyone gets to program. Even my 3-year-old daughter in kindergarten, they have this yellow plastic bee with some buttons on its back. And the kids, they program movement patterns on
And in
this
Estonia is mandatory. Are there any Estonians here, by the way? Estonia mandatory programming, learning from first class onwards.
Yeah, this is kindergarten. They start with it before that, actually.
Yeah.
So it's, and that's
right.
not only incredibly cute, it's also incredibly important from a diversity and democracy point of view.
Excellent. So here we have audience questions. I will put the microphone here and I will go back to moderate. So go ahead.
Yeah, my name is Gregor Engels, and I was sitting next to Kurt and I had the impression that you have forgotten that there's an audience here, but also would maybe like to ask some questions. Yeah, thank you. So, by the way, I'm a member of Informatics Europe. Informatics Europe is a European organization, and we have an initiative together with ACM on informatics for all. But this is only a side remark. My question to you is, or maybe to the whole panel, do you really think that in 2030 it will still be the case that only software engineers can define software engineering? So we speak about non-functional properties like ethics, legal things, psychology things, and so on. So what I would like to say is, in 2030, I hope that there are at least half of you are not computer scientists.
No, I second this. I think we really should think about how we grow software engineering, like a conference like ICSE or any software engineering community beyond software engineers. And I think it also means that we need to be more accepting towards people who have like our backgrounds and who maybe not what we think is the typical type of ICSE paper, ICSE presentation. Because, and to some extent we're seeing this already now, right, with all the new privacy regulations, like we have so many discussions with privacy experts and with lawyers, and there's so many aspects you need to take into account. So it's really, software engineering is not just, we need to know about the software, you need to know about many different things and also about the domains. And I think we will see much more, like software engineers, like people who write software need to have many more skills than just writing software. And I think it's also, because you're mentioning how we can increase diversity, I think it's really important to change perception about software engineering. Because when you talk to a lot of people, how a software engineer or a programmer looks like, they think of like a guy sitting in a basement in front of a computer, writing 20 hours per day some source code. But that's not how software engineering is. It has so many other things which are not about source code or about programming.
Thank you, Tom. Let's go. Leonel, I want to say a comment.
Yes, it's actually related to what I was saying before. We need more interdisciplinary research at the intersection with other domains, because software engineering is always applied to another domain. I mean, there is no software engineering in isolation that is disconnected from application domains. And of course, that means that there is a need for, much
Now we
more.
go to the next audience question by Kurt.
Okay, I'm Kurt Schneider from Leibniz Universität Hannover in Germany. And I want to tell you a little story. Since we are talking about the future, 20 years ago, I met a colleague in the United States, and I told him, hello, are you still working in artificial intelligence? And these were different times. At that time, he said, oh no, I don't work in artificial intelligence. I never worked in artificial intelligence. I was always a software engineer. So it was embarrassing for him to be associated with artificial intelligence at that time. When you look into 2030, will we again absorb the artificial intelligence, machine learning and deep learning, or will we meet at an artificial intelligence conference? So will they absorb us, maybe?
So is AI eating
I don't
us?
agree with you, because I think artificial intelligence community, I mean, when you use machine learning techniques, one of the limitations you have is that they don't really provide explanation about why a certain decision is taken. And this is actually essential for software engineers, especially when some decision that software takes needs to affect human, and human needs explanation. So
I would say we still stay software engineers and don't turn into artificial intelligence people, right?
yeah.
But artificial intelligence,
not sure.
Artificial intelligence is a means to an end. So, we can perfectly use artificial intelligence to solve problems. That doesn't mean that we do research, in artificial intelligence.
Markus.
So that's,
Yes. And I think this means the end will be increasingly popular here in software engineering also. So I think both types of conferences will remain and be active still in 2030, but we will use it here as a natural component in our systems.
Excellent. Let's move on for the next audience question, please.
So I would like probably to make a comment, but I think it's very much for debate. So there's this thing which surprised me here, mostly in what Liliana is saying, and I agree with many things, but not all. So about ethics, about the software influencing our decisions. I don't think it's realistic to hope that software will not influence our decisions. The environment in which we live influences our decisions. Software is part of our environment. It is already influencing our decision. The other thing you said also, which it's still very connected, we don't know what ethics is in this context. And I think this is really a key observation in the sense that it's not what we don't know what ethics is, because we are not the people who should know what ethics is. There are philosophers where the question is what ethics is. And what we say a lot is that people who get exposed to STEM have an advantage, so we should make more people exposed to STEM, which is absolutely correct, I totally agree. But I think a large part of the problem comes from the fact that software engineers are not exposed to humanities. Many problems that we have now come from the libertarian nature of the geek who grew up in the last 20 or 30 years with this libertarian culture, and that's what brings us to a situation where we are. So we should expose software engineers to humanities as well as expose other people to STEM, and then we will have a more balanced society with software influencing our decisions, but maybe in more balanced ways.
So I have a personal note on this, exposing us to humanities. When you said that we are not the right people to study, for example, ethics, in my research team, we actually did study productivity and software developers and followed proper psychological tools and came up with the conclusion that the happy developers are more productive. Now it was widely popularized, and in China especially, it went wild. But we had really hard time getting it out, because conferences are telling that this is psychology problem, this is not our problem. That this is not computer science, this is not, then we tried information systems, it's not information systems either. So you're in a way, a young researcher may find himself in a limbo, that none of the communities are accepting their work. Am I hallucinating, or is this an observation that you might have, or do you want to comment on this? The panelists.
I guess, again, you're talking about interdisciplinarity, and the software, it permeates everything, so we need interdisciplinarity in all possible directions.
Is this field open to this interdisciplinarity that we talk about?
I mean, that's a typical example where we need interdisciplinary work, but there are practical problems, though. There are practical obstacles. It's very hard in academic environments to, actually implement such interdisciplinary projects. For many reasons, because people want to publish in different venues, people tend to focus on their own research community, interdisciplinary work is harder to publish. So there are many practical obstacles in the research world to interdisciplinarity. So though governments and public authorities would like to see such research happen, somehow the academic system is not particularly well designed to facilitate such interdisciplinary work.
All right, I think that we take the next question from the audience now, so go ahead, please.
Yeah, hi, I'm Tony Clear from Auckland University of Technology in New Zealand. And just responding to the ethics question, and sort of a bit of a sad story, I suppose. Probably a dozen or so years ago, I was working with Don Goddebarn, who's just producing a new version of the ACM Code of Ethics. He was with us in New Zealand for a while, and he produced the Software Development Impact Statement, which actually had a case tool associated with it. It was a whole set of ethically embedded questions, which would be conducted. We developed a thing called a SOTUS inspection, where essentially you would take a project before it's starting, and instead of just looking at the customer and the developer, you actually looked at the stakeholders who'd be damaged by this software that was about to be built. Could we get that taken up by anyone? No. Organisations don't want to know. Software systems get initiated with a great rush of blood to the head. No one wants to hear any thing against it until it starts breaking, and then they have the post-mortem.
I feel like that's not true. So Google actually has a lot of people working on like privacy and security, like that aspect of ethics, like making sure that we take our users' data seriously. And so when you are launching a feature or a new product at Google, like you work closely with people that are experts in privacy and experts in security to try to make sure that you don't do anything bad. I mean, people still do something that doesn't turn out as we would like, and you know, we have a post-mortem to figure out what went wrong and prevent it the next time. But I feel like we actually do have a lot of guidelines and help and committees to talk to and things like that to try to
inside Google now today. Is that information available elsewhere outside, and what is the adoption rate in other, let's say?
I don't know how what other, maybe you guys can speak to. I feel like there's probably similar things at Microsoft and Facebook for like small startups. Then a lot of times it's more just just trying to do cowboy style, whatever you can manage in a short amount of time. But I feel like this is,
just responding directly on the Google one, though. I mean, I actually wrote a column about the fact that my PhD students got the joy of doing a Google search and finding out how people would write their assignments for them, including their PhDs for $50 a page. So Google's business model and its ethical model may be different.
You mean in terms of, so there's software development at Google, so just focus on the software development side.
Well, I don't think you can. This is the issue.
There's a separate question, like
Google's basically regarding data as neutral. So if someone puts in data about how to be corrupt, that gets spread to everyone.
So in terms of search results, there's also a second question.
And they pay for it in their AdWords.
There's also a second question, like your email data or things like that. So like like from Google's perspective, I think we do separate these. I mean, I'm speaking for myself, not for Google overall, but and
I'm not saying Google has easy problems. When you've got serious problems.
So I think it's like for this question of ethics, there's like definitely different dimensions. There's like, do you consider ethics when developing software? Do you think about the ethical considerations? Like, do you think about privacy implications and so forth? There's also in terms of like the internal side and how you store user data and things like that. There's also the external side, like is what you're building a good thing? I mean, we also try to do that, but I think there's a lot of disagreement over what that means and like what, if you use a tool to do a bad thing.
With the interest of time, I think thank you for the question, and let's, Ita, please go ahead.
Hi, Ita Richardson from LIRO, the Irish Software Research Centre in the University of Limerick. I hadn't thought about diversity until you brought it up, Caitlin, as something I was coming into. So I'm going to say in 2030, I would really like that I'm not living in a world made by men for men. And my example that I really use is because I was doing something this morning, I had to think about what I was wearing because the clip on the microphone doesn't work on a dress. Okay? Big problem all the time across conferences. And and the third thing about that is I would really like that young women would not have to be thinking about the opportunities for the women behind them and that they could focus on their software engineering research, unlike many people nowadays, because the women have to do it and the men aren't supporting it. So we need men to be supporting what's happening. I think that's really, really important. But what that does bring me to is to help solve this problem. Part of that in my book, and I could talk all day on this. You don't want to hear me talking all day. But the one I'm going to pick up on is the interdisciplinarity. So I know Liliana in UCD is working on an Athena Swan team. I'm working on an Athena Swan team. And one of the things we've actually been looking at is, for example, biomedical engineering in the University of Limerick, which has about 80% commonality with mechanical engineering, is actually getting in the region of 40% women for the last 5 years. Biosciences, bioscientific computing, I think it's called, in Brunel University in the UK, are up in that region of women as well. So we're actually now looking at interdisciplinarity as being a way, and we have to move forward, as far as I'm concerned, to being interdisciplinary. We cannot stand on our own, and I can understand the problems Lionel is talking about from an academic perspective, but we really, really have to be thinking about not being standalone software engineers. We have to become more interdisciplinary for the sake of software engineering, but also for the sake of diversity.
All right, I thank you for the comment and statement. From the panel, is there something to add?
I would like to say really quick, like we've talked several times with diversity about attracting people and kind of, broadening what software engineering means and interdisciplinary, but we also have a retention problem and like an attrition problem where people leave software engineering at a higher rate, for example, if they're women. And so we also need to think about that side and not just bringing more people in.
All right, thank you. I think that we have one more audience question, please.
Hi, Gülçe Lıklı from Chalmers University of Gothenburg. I have a question to Lionel Bryant. Nowadays, on Twitter, I'm seeing some advancements in developing software development environments for quantum computing, and also programming languages, and also for some, also these kind of technologies. Of course, these are prototypes being implemented, developed in research laboratories for quantum internet. And there's some research going on, software engineering for quantum internet, quantum computing. And on the other side, you said that software engineering should be software engineering in practice. We should focus on real-life problems. But we also need to introduce some techniques to do software engineering, incorporate these technologies into software engineering. So what do you think? Should these kind of research be part of software engineering, or should we think them in outside the box? Because we need to start from somewhere so that they can get established in the industry and be used by developers.
Yes, I understand your point, and I agree with what you are saying. When I say that we should root our research on a better understanding of practice, that does not necessarily only include current practice, but also foreseeable practice. But I don't think that any way we can really truly understand or truly predict the future as researchers if we don't even understand the present. The future doesn't come out of nowhere. So I've already, I've had that discussion with several colleagues in the past, and they were telling me, I'm solving the problems of the future. I'm not interested in talking to engineers. But, and my answer was always, how can you be bold enough to claim you understand the future, or you can predict the future, if you don't even understand the present, and what are the current industrial trends and the current, technologies people, industry are using. Like, for example, the keynote this morning was very insightful with that respect. Well, I was not restricting my statements to necessarily current practice, but at least foreseeable practice that is rooted in a thorough understanding of engineering practice.
We are now closing into the ending of the panel, but I wanted to hear from the panelists. You are all experienced working with in the industry, academia collaboration. So what are some of the best practices you have noticed working with industry, or vice versa, industry working with academia, that you want to recommend to others as we want to bridge in, and the whole industry forum day is about, let's say, bridging the possible gap there is. So would you like to highlight some of the things that you have learned in your career that you have found working?
Some of the practice in agile development, not surprisingly, are pretty effective, like, incremental development, early feedback from users, for example.
So quicker feedback cycle between the research and industry.
Yes. I mean, there are many other examples, but I'll let the others contribute.
Go ahead.
Google has a visiting faculty research program and intern programs where people that are doing research outside come in for a short time and collaborate with people internally and kind of can access data. And
is it working?
Yeah, I think so.
All right.
I mean, I think not as many people know about it or take advantage of it, but I have a few papers at the conference that are a result of this process.
What about others? Best practices? Want to share?
Identify a champion in the company, always a good thing. Communicate a lot and start projects together, basically.
All right.
Yeah, I think it's really meeting developers as often as you can. And as Lionel said, get feedback early on. And because if you just go off with an idea and don't get any validation from developers, you probably run into the wrong direction.
Liro is funded by now 50% by industry money. So, and for us, industry has been giving us ideas, research ideas. So, from my experience, collaborators from industry have been from the real problem gave us opportunities to find new research projects that then could lead to research papers. So
thank you, Liliana. And then we have Mark with the idea as well.
So I want to underscore what Caitlin said. So, you know, as academics, it can be quite seductive to take an industrial data set and apply our techniques to that. And I've done that, and I think it's a good thing. It helps us to understand whether our work is applicable. But, you know, if you actually place a student inside a company as an intern, then that student will come back with new research questions as well. So that does more than just validate your existing research. They may go in with a particular idea about some research they want to validate, but they will come back with all sorts of new ideas. And the other thing you can do is, if you actually feel that you want to do this, is as well as maybe placing one of your students in a company, you might actually go yourself. And there are lots of programs at many companies. I obviously can only speak for Facebook, but we have intern programs. We have hundreds of PhD students in the company at any given time. We also have programs for master's students to do interns and fellowships. So if you want, even seasoned academics can come and spend time working with industrialists in the company. Right. And I would recommend it as a very good way to cement a real relationship with industry rather than just playing with industry data.
Thank you. Thank you for that. Lionel, of course you can say...
Just something short I'd like to add.
Short.
Your question is actually a very difficult one. What are the good practices you have seen? Because I don't think that there are many good practices that are actually valid across all domains and all types of systems. I mean, good practices in the context of cyber-physical systems or good practices in the context of distributed financial applications are not the same, mostly not the same. So we can come up with a few general examples like what we just discussed, but we're not going to go very far. So it's a very difficult question, actually.
Thank you. I'm aware of that. Tom, do you want to...
I just want to say we have the same programs as Google and Facebook.
All right.
And Google.
To go spend some time. Okay, here comes the final round very quickly because we are now nearing the end. So we are inviting all of you. So it's good to do a bit of planning. So 2030, you all will be the keynote speakers. So we have lined up a nice set of keynote speakers. And now that we can start marketing the event early, like super early, we would like to know the title of your keynote in 2030. You don't have to say the abstract, just the title. And with that, we will conclude today's panel. So title of your keynote 2030, and we can start with Mark and move this way. So Mark, go ahead. What will you...
Thank God I'm still alive.
All right. Mark is still alive. Very good. Lionel?
Well, along the same lines, how I survived so many years of ICSE and still keep my sanity.
Thank you, Lionel.
You know, but more seriously, I don't have a title, but there is a topic that, you know, I'd like to be able to talk about, you know, in some years, is that right now we have techniques that provide guarantees on critical and mission-critical systems, but that don't scale. And we have heuristics that help us find bugs and problems, but they don't provide guarantees. Eventually, I would like to have a technology that I can talk about that allows me to talk about degrees of guarantee, trade-offs in terms of guarantee. whether it's safety guarantees, security guarantees.
Thank you, Lionel. We need to move on. And Tom, what is the title of Tom's keynote?
So it's going to be how we understood software development less and got away with it.
Excellent. Thank you, Tom. And then Caitlin, please.
Paxos is the new quicksort.
Hurrah. Liliana.
Software engineering for cyber, physical, and social systems.
All right. And Markus, the last one. With
The last one,
title.
yeah. And I just added a new suffix to the title. So it will be engineering high assurance systems that keep learning, a life cycle perspective, infused by ethics, because I think that's...
All right, we have to work on this. It's not very selling yet, but it's okay. I think that, ladies and gentlemen, in the very first industry forum ever held, the panelists, thank you. And this